Hey, welcome to Chapter 1, Lesson 9, uh, Patterns, Equations, and Graphs. So, our objective is that you will be able to use tables, equations, and graphs to describe relationships. In the warm up, you looked at a situation where somebody was staying in a hotel and the number of nights that they stayed determined how much it costed. So there's a relationship between the nights and the price. And in that case, and in most of the cases we'll be looking at for the beginning of this class, it was a direct relationship because every night that you stayed, the price went up the same amount. Um, so we're going to look at how do we connect that to tables, which we've seen a bit of already, equations, and graphs. Um, so just to review, in the last chapter, you were looking at evaluating situations like this. 6 equals 2n minus 8. Um, this is an equation because there's an equal sign. It's not an expression because that would mean there was no equal sign. And it has one variable. So this is a one variable equation. And one of the things you were doing is evaluating this when, for example, we had a 7 here. And then the question would be, is this true? The 7 here means that I'm going to plop the 7 in for n, and I'm going to evaluate this equation and say, is it true or not? I'll just do that really quickly. So 2 times 7 minus 8. 2 times 7 is 14 minus 8. 14 minus 8 is 6. And 6 equals 6. So I would say in this case, if I was doing this problem for my homework, I would say that this is true, or like, yes, this number does work. So what we're going to be doing in this chapter, or this lesson, is we're going to be doing a similar thing, but for variables, equations with two variables. So let me show you what that might look like. That might look like this. Y equals 4x. And now I have y and x. I have two letters. I have two variables. We're mostly going to be using y and x when we have two variables. Now, how would I evaluate this? Well, I'd have to be given two numbers. Like, for example, here I had one variable, I was given one number. Here I have two variables, I'm going to be given two numbers. For example, 3 and 10 could be the numbers I was given. But we have a little bit of a problem here because, well, here I knew the 7 plopped in for the n, but here, where does my 3 plop in? Does my 3 go in for the x, or does it go in for the y? And so there's a convention in mathematics, just something that we've all agreed to do it the same way, and that is that when we write an ordered pair like this, we put it in a specific order. So two numbers like this is called an ordered pair, and the first number is always x. So I know my 3 is going to go in for the x, and the second number is always y. So my 10 is going to go in for the y. So I'm going to end up with 10 equals 3, oops, 4 times 3. Got a little bit ahead of myself there. So now this isn't necessarily true. The question here would be, is this ordered pair a solution to this equation? And now that we have substituted our values in for the appropriate variables, I can check, is 310 a solution to this equation? Well, let's see. 4 times 3, that is definitely not 10. That is 12. 10 equals 12. No, sir. So, not a solution. 310 is not a solution to this equation. So, in just a minute, you are going to evaluate two variable equations given an ordered pair, and you're going to determine whether that ordered pair is a solution to the equation. Before you jump into that, there's one other thing that I should point out here, and that is that ordered pairs, they are very closely tied to the coordinate plane. So let's look at the coordinate plane here for a second. So the coordinate plane has two main axes, just like the ordered pair has two numbers. So we have an x-axis and we have a y-axis. And the x-axis goes in positive numbers in this direction, like 1, 2, 3. And negative numbers in this direction, like negative 1, negative 2, negative 3. And the y-axis goes negative as it goes down, and positive as it goes up. So, if I was given the ordered pair, for example, 2, 5, I could also represent that as a point on the coordinate plane. So 2 is my, remember which one goes first, x or y? I like to remember that it's in alphabetical order. So in the alphabet, x comes before y, just like in ordered pairs, x comes before y. So my x is 2. So I know that my point is going to be above or below this 2. And my y is 5. So I know that my point is going to be where x equals 2 and y equals 5, which an easy way to do it is to start at the origin, go over 2, go up 5. There's your point. That is the ordered pair 2, 5, represented on the coordinate plane. Okay, so that coordinate plane thing will come back in a few slides, but for now, try evaluating some equations with two variables to see whether they are true for a given ordered pair.